What's up, everybody? It's Mr. Tannen here, just making a quick video for you. So I just got this question about a specific problem here that's telling us that the graph of a sinusoidal function has a maximum point at 0, 7. I figured the person that sent me this problem was just, for some reason, the coordinates got repeated, but then intersects the midline at 3, 3. Write the formula of the function where x is entered in radians. So, there's a few key pieces of information here. First and foremost, we can see if we were to graph this, which I did here, we could graph this by hand, obviously. It's just a sinusoid that has its maximum here at 0, 7, and then it's hitting the midline at 3, 3. So there's a few things that are easy for us to figure out. First of all, we can see that the midline is at the line y equals 3, because they told us that that's where it intersects the midline, and we know thus, because the maximum's at 0, 7, the amplitude is 4. It's going 4 above and 4 below at its maximum and minimum. And the period, this is maybe the trickiest part. Well, since it's just going over from 0, 7 to 3, 3, that's actually, if we thought about it, it's just 1/4 of the period. So the period is 4 times that 3 x values, right? 1, 2, 3. So the period is going to be 12. So this is going to harken back to my most recent video where, first of all, I'm going to choose, you could actually use sine or cosine to represent this graph. The thing is, if it were to be sine, we would have to include a horizontal shift, whereas we know cosine starts at the maximum. So I think it may be easiest for us to use a cosine function. So you may remember this format we talked about, where we have a times the cosine of bx plus c. Well, in this case, we know the amplitude is 4, so a has to be 4, because that corresponds perfectly with the amplitude. So we know it's going to be 4 cos. We know that the period is 12 and the midline is 3. Well, we know the midline is just going to be the vertical shift up 3, since it's from 0. What's the trickiest part here is finding out what we're going to put in for b. Well, we know the original, we know that we could find the period by doing 2 pi divided by the absolute value of b. Let me rewrite that absolute value of b. So, and we know then that the period is 12. So if we want to solve for b here, well, we'll just solve for positive b, because I think in the positive or negative, it's actually a horizontal reflection of itself, so it doesn't really matter. But what I'm going to do here is solve for b. So I'll multiply both sides by b. I get 12b equals 2 pi. Well, now I'll divide both sides by 12. And I get that b equals, well, that simplifies to pi over 6. So b is just going to equal pi over 6. Which makes sense, because if you notice here, rather than being in terms of pi, it's just in terms of units, right? Which the only way that would happen is if we had a pi in our b to cancel out the pi in our original 2 pi period. So the actual function here is going to be 4 cos of pi over 6x, or it could be pi x over 6 plus 3. This would be my function that represented this graph passing through these 2 points. Again, like I said, it could have been with sine. The 4 and the 3 and the pi over 6 would be the same. We would just have to add or subtract something from x because we would have to shift it. I guess it could be, it would have to be a shift left 3, so maybe it could be x and then we have plus 3 in there. But that just, like I said earlier, just becomes more complicated than necessary when we could just do it with cosine. Hope this video helped, and you could graph this on Desmos and confirm your answer, and it would end up working. Hope everybody's doing well.